is good to see all these people coming, and it was a little worrisome. I mean, I'm not one of the organizers, but I did want it to be a success for all of us, and it's turning out to be good. Also, it's been a chance to bring together some of the people that I have interacted with over many years, that I've learned from. We have a few people here that were like some of the inspirations for DDD, like Ward Cunningham and Rebecca Worf's. Yeah, Ward Cunningham. If you start looking into the history of the things we do, I mean, okay, so there's the wiki, but all the things we do, you know, the history behind Agile, and the history behind patterns, the history behind object design, and all these things, and then there's always Ward there. But I remember, you know, a deep thinker, a subtle thinker, you know, that's what I find so fascinating. So be sure to listen to his talk on Friday. I will. And Rebecca, you know, domain-driven design, the reason it's called that, there are a whole bunch of something-driven somethings now, and if I had realized just how many there would be, I would have probably found a different name, but at the time there was only one something-driven design that I knew, and that was responsibility-driven design, and that and some other things that came from Rebecca Wurzbach, who's also here today. She'll be talking tomorrow night. And there are so many other people here that have been so important in the evolution of this thing, and I won't just go through the whole list, but you know, this is a pretty unique gathering here, I would say. And we've had some good gatherings in Europe, but this is the first time that we managed to do it here, you know, in our country, so that's really good. Well, now, this talk, I'm going to talk about what domain-driven design is and a little bit of why is it that after all these years, because the book came out in 2003, so that's 14 years ago, and it was written in the years preceding that. Why would a topic from 14 years ago still be relevant? Maybe a little more relevant than it was then. I mean, to say in terms of interest, we couldn't possibly have gotten a conference like this 5 years ago. So what is it? And I'm going to try to speculate about that a little bit. But most of all, try to convey what I really think domain-driven design is. And that's a funny topic to choose for a room full of people who have just signed up for a conference called Explore DDD. But it's a question you have to keep asking because it's a subtle kind of thing. It's like, you know, people have asked me that question an awful lot of times. And so I think part of the problem is that it's not really a reductionist thing, you know. It's not a simple formula. I mean, part of it is that we really value certain things, focusing on the core complexity and opportunity in the domain. Even today, and even more so, I think, back when I was starting in software in the 90s, that there was really good software developers gravitated toward very technical problems. And that was what was considered, you know, the most sophisticated, the most valued activity that a software person could do. And so that drained away from the actually building of the business logic. I remember on one of my early projects that I was working on something as a junior developer, and they kind of recognized that, you know, I had some skills. And so they said, well, now you can work on the database integration framework, which at that time, you know, you had to build all your own stuff for that stuff. I mean, we didn't have frameworks to just grab. And that was meant to be an honor. I mean, I knew that they were saying, oh, you're one of the good ones. You should be on the technical infrastructure team. So I agonized about what to do, and I went to the project manager of the project, who's a very smart guy, and I said, I realize that I really appreciate the vote of confidence, but I think what I'm most interested in is some of these interesting business problems that we're dealing with on this project. These are really complicated issues, and I'm enjoying digging into some. And the guy, I thought he was going to kiss me. I mean, it was amazing. He said he had never had a software developer say anything like that to him before. He had never heard anyone say that. And that's basically the attitude underlying domain-driven design, is that it is driven by the domain, right? The business that we are trying to help, and the complexity. We have to have a genuine interest in all that stuff. And we focus on that. So, of course, that doesn't mean we don't have to do the other stuff. And then there is an exploratory aspect. Of course, this conference called Explore DDD. And I think that's a deliberate sort of double meaning of the word, because on the one hand, you're exploring the topic of domain-driven design, but also one of the big themes of DDD, and in this conference in particular, is exploration of the domain. And exploration, looking for different models, because there are different ways to look at a domain. And if you can find the right way to look at a problem, sometimes just falls apart into something you can deal with. Something that seems overwhelming, and you look at it this way and this way and this way, and then from that angle, you can see the answer, the way to tease it apart. This kind of exploration is not a part of routine software development on most software projects. Even in an agile process where we say, well, we're taking it a step at a time and going forward a step at a time, and that has an aspect of exploration, but still, because the whole system is moving forward, there's only a limited ability to look to the sides of where you're going. Well, that depends on the project, but I'm talking in general about most of the projects I've seen. Now, a third component of domain-driven design is that we actually are going to write software, and write software that expresses those models explicitly. So even this write software, many times people have said to me, these techniques seem like you could do this for like business analysis, talking about the business problem itself, or strategy for a company. And I say, I suppose you could, but that's not what I know. That's not what I am interested in. And for me, it's about software. Ultimately, we are deeply interested in the domain, but what we're deeply interested in doing is saying, we're going to help that domain, the people in that domain succeed by building great software that supports what they're doing and maybe helps clarify and so on. So we're right in there with them, and that may lead to some actual business innovation for sure. But there's software there. But that software isn't just, okay, we've written some software that's really useful for business people, but we have structured that software around a concept of the domain, around that model. And so that, of course, is not unique to domain-driven design, but it is a feature of it. And finally, in domain-driven design, there is this heavy emphasis on language. And I think this might be the most distinctive aspect, right? Because all this other stuff is like, yeah, this is important to us. This is important to us. We do this thing that a lot of other people do, but it's especially important to us. But there's emphasis on language to say, if you can find a good language to talk about the domain in and structure the code around that, then you're most of the way there. That if you can express that problem concisely and clearly so the business person can speak the same language as a software person, we really emphasize that. That's that ubiquitous language pattern. And it's not just a technical thing. Oh, look, the code reads like a description of the business, but we speak it. We speak that same language. And combined with that, there's this concept of the bounded context. Context being, of course, a key thing to language. I can't understand what you're saying if I don't know the context of what you're saying. Language is meaningless without context. So we pay attention to the context and explicit boundaries of that. And I think that if you look at these 4 things, you kind of have domain-driven design. That 4th being the most distinctive. That leaves a lot of room for the details of how you do it. And that, I think, is one of the reasons that it's still a going concern, and 14 years later. Because if you described in detail, and in the book, I do make detailed descriptions of like, well, this is the way you might do this thing. And some of those seem a little dated because they're based on the way we did things in 2003. But the principles here are not dated. These things will be relevant until Skynet makes us all. So it's not a reductionist philosophy, though, right? It's not like, so I can't just say, this is the definition of DDD, and these are the things you do, and this is the step-by-step process. It's more like a way to approach this thing. And it's some terminology. The terminology, I think, is important. I think to value language is one thing, but to say, well, we're trying to cultivate a ubiquitous language, and what we mean by that is somewhat more specific, and we can really talk about that. Or to say, well, we're partitioning our system and trying to, respect these different parts. But if you say bounded context, and what I really mean is these sort of linguistic boundaries that are manifested in the software some way, and we have very explicit translating layers in between. That's not the same as just saying, oh yeah, we've partitioned our system. There are many approaches to that. So the terminology does matter, I think. Now, if you're going to judge something like this, if you're going to say, well, should we be doing this thing? Because another part of me says, it is great. We've got a couple hundred people here, and it's 14 years later and all that. But on the other hand, we don't have, 1,400, we've got a couple hundred people here, right? We don't have a couple thousand people here. We don't have projects all across the land doing this and, by the thousands. Well, and so there is a level on which you say, it's not like domain-driven design is a smash hit in the real world, right? And I am not a dogmatist. I do not believe that domain-driven design is like the right thing to do. It is not a religion. I don't believe in domain-driven design. It feels right to me, but then again, I see projects try it or say they're trying it and then not succeed. I see projects actually trying it even with my guidance, and we make some headway, and then factors prevent success. And sometimes those factors make me think, this is not a perfect approach. There are things here that maybe the thing is too fragile. I don't know. But I guess what I'm saying is, I think that if a thing doesn't help you deliver, then you should be very suspicious of it. That includes domain-driven design. It includes everything. Another way of looking at it is, does it help us adapt? Like, there's a lot of change in 14 years, so it's helped us adapt. I would say that that's probably a safe one. And does it help us innovate? I'll talk a little more about that one and what I mean by that. But basically, in a way, I mean, has the concept of DDD led to other ideas sort of within that space that have exceeded the way that we envisioned doing DDD at the beginning? Okay, so anyway, back to what DDD is, the definition. Well, I talked about this triad of the language and the model and implementation sort of bounded together, and maybe there's a little bit of money involved, and also there's a nice triangle there, so I had something in mind with this slide. I don't know. Anyway, but there are 3 things in that triangle. So what is a model? Now, what is a model is pretty important to be able to answer if you have said on the slide that says, what is DDD? And one of them is talking about exploring models in collaboration with domain experts. And one of them is talking about building software based on the model. So I used the word model twice. I should say what it is. And the problem is not that you don't know what the word model means. Of course, everyone knows that word. But you know a lot of definitions of the word model. You know so many meanings of model. And even within the software context, you still have multiple meanings of the word model. Like UML diagram. Right? Very often, and I do this too, we put up draw up a nice little class diagram and we say, well, here's the model. But that's not really what I mean. And it is a particularly unfortunate shortcut, I think, because when we reduce it to that, we lose a lot of the power behind a model. So if you look at a map, and it's often, and then people say, okay, a map is a model. The world is the domain and the map is the model. That's a very common way of defining model. And of course, that's absolutely a meaning of model, and it's close, but it isn't quite what I mean still. But I want to use this map to talk about this. And many of the people here will have heard me make this point before. In this model, though, or rather, in this map, we can look at this map and we can learn certain things. You could say, if I go east from New York City, where will I end up? And you'd say, well, if you go far enough, you'll end up in Portugal. Or you could say, how big is China? Well, China, it looks like on the map, is about the same size as the United States. In geographical area, I mean, of course. And in fact, that's correct. So I can learn some things by looking at this map. And then, of course, I can say, well, okay, then Greenland and Africa, they look about the same size, too. But, of course, if you think for a moment, you realize, well, wait a second. Greenland and Africa are not the same size. So what's going on? Has the map makers made a mistake? Like, is this just, this map's over 100 years old. Maybe they just drew it wrong. But, of course, that's not what it is. And most people realize, well, the reason that Greenland looks so enormous and Africa looks relatively small is that this is a projection. The Earth is round, the map is flat. We have to flatten it out. And to do that, you have to distort things. In this particular case, it's what's called a cylindrical projection. If you took this map and you rolled it into a cylinder, the east and the west would meet up. That's not true of the north and the south, right? And so you have a cylinder map. And you cannot make a ball project onto a cylinder without distorting something. But that isn't a full explanation, because there are ways of doing it without distorting the size of the land masses. For example, here is a projection of the Earth's surface. And on this one, the size of the land masses are in proportion to their true size. So now you can see Greenland. The center is the North Pole, right? So there's Greenland. Not so big anymore, huh? And there's Africa in the lower right, enormous looking. Like closer to the size of Asia than the size of Greenland. So we have a different projection, and we get a different view of the world. And both of these are maps, and in that sense, they're both models. But if we look at, again, at this Mercator map, this map was not just, this of course is the map of the world. If you were in school, you probably saw a map like this. And if you were in school in Europe, you probably saw the very same map just rotated about, a few thousand miles so that Europe's in the middle. The only difference between the world maps we use is if we put ourselves in the middle. Now, the Australians, and Paul will have to tell me, yeah, they tip it upside down. And I say upside down, right? So basically, we all use this same one. And that's a strange thing, given that there are literally an infinite number of possible ways to project the surface of the Earth onto a piece of paper. But the reason is historical. This map was developed for a very specific reason. I think in the 1590s, there was this Belgian guy named Mercator, and he was a map maker. And he came up with a clever way to make a map that was very useful to navigators, his primary target market. And it was useful to them for a very particular reason. If you look at this map and you want to know how big something is, well, you actually can figure it out, but I'm not going to go into it. It's a little complicated, and it's really not that important to most navigators. But what is important is the direction of things relative to other things. On this map, you can draw a straight line between two places and measure the angle of that line, and that corresponds to a compass heading. And you can do it between any 2 points. That's an amazing property for, a flat surface that represents a round surface. But that's what this map can do, and that's what made it useful to navigators, and that's what he made it for. Now I want to talk about what I see as, what is the model here? Not the map itself so much, but these things that are used to make the map. So first of all, how do we think about the domain? What is our concept of it? Well, one thing is we're abstracting the Earth as a sphere. We're saying, well, this thing, which is actually a very complex thing full of matter and all sorts of stuff, is just a geometrical shape. And then we say, actually, we're not interested in everything we know about that either. Just a few things. Specifically, the location of certain points on that surface. We'll express those in latitude, longitude, a spherical coordinate system. And we probably don't even, like coastlines, navigable rivers, the location of important port cities, those kind of things. Mostly, we're not interested. So then we need some math, or as we sometimes refer to it when we're doing the DDD thing, established formalism. In this case, I'm talking about the cylindrical projection, a function that can map points on a sphere onto points on a cylinder. That's a modern mathematical way to say it. Mercator didn't say that, but he did something, though, that was mathematically equivalent to that. So let's just say that. Now, finally, an assertion. The assertion that the angles are preserved, right? That the direction of that line will be the same as my compass heading. And that forced the choice of the projection. There's only one projection that does that, and that's Mercator's projection. And these are the things that make powerful models, the kind of models that really are useful to our domain stakeholders. If you want to think, if it's not completely obvious why I think of this when I think of our software development process, imagine we took a different data set, not this relatively modern one from like the early 1900s, but one from, say, the late 1500s. But we applied the same model. And we would end up with something like this. Well, this is the actual original Mercator map. And this was, the product he sold. Not this whole world map. He would sell extremely zoomed in pieces that, so if you were going to sail, say, from, through the Mediterranean, you'd buy the pieces along the Mediterranean coast. Okay, so it's interesting. You look at this map and you see the contours of Europe, they look really familiar, as in they look like a modern map. Good data, because they had sailed a lot around those parts. And around the Mediterranean is pretty good. The Middle East, India looks okay. If you go over to the east coast of the Americas, you can still recognize it. The proportions are a little off. But the west coast of the Americas is a bit of a mess. Like, look at South America, the west coast of South America. Actually, there's a lot of detail there, and the detail isn't bad, but the whole thing seems to be shifted hundreds of miles east. It's like there was an offset error in the data. That sounds familiar? And then look at the west coast of North America. It's like, well, we know there's a west coast there, so there you go. It's sort of interpolation, right? An approximate interpolation where you're lacking some data. Now, there's some areas where they just like whatever that thing down in the lower right-hand corner, it might be roughly where Australia is, but I don't know. I mean, they're just wrong about that. But, and so you think, okay, now what do we do? Well, of course, we're in all sorts of different domains, but sometimes we take a big, messy collection of data, and we have to select out some relevant data. It's actually relevant to some decision, right? Some business decision needs to be made, and they just awash in data. But data by itself isn't that useful. So you're drowning in data, and you say, well, I'm going to select out a little bit of this data. You apply some abstractions to it to make it mean something. And then maybe some mathematical massaging. And now I've got something I can make some assertions about. And boom, maybe if you choose the right one, it's really helpful to that decision-making process. The confusion is cleared away. They can see the consequences of their choices. In this case, it makes it easy for a navigator to know what direction to point the ship. Not easy maybe, but it's a lot easier than it was before. So this is what I mean by a model. Stuff like this. And this is why I say that if we dumb it down to a UML diagram, we've lost so much of what made the whole thing have a point in the first place, I guess. Now, when I talk about it, I realize I have fallen into this, where you say something like, that's an interesting model, but does it really reflect the reality of the business? And I have trained myself to stop saying that, because every time I say it or someone else says it, I realize that not long after that, we're way off track. That's just not the thing to be thinking about. Is that realistic? Is that picture of the world realistic? Well, I mean, after all, Greenland and Africa are not the same size, but Mercator didn't care. Or is this? This has Africa and Greenland in their proper proportions, about 14 times, by the way. But I don't recall those big triangular and angular cutouts from the world like that. There's something off about this one, too. There's a realistic picture of the world. That's realism. How useful is that, though? I mean, for your typical navigator, let's say. Realism and usefulness are not the same thing. Another thing about models that become useful is that they have a narrow focus. So completeness is one of the things that people fall into sometimes. And they'll have a lot of data that needs to be stored, represented somehow. And so they will say, well, it has to be in the model somewhere. And then you end up with, a comprehensive model. But comprehensive completeness doesn't give you that usefulness that the kind of narrow-focused model does. So sure, sometimes you need to have a database that stores everything. But let's not equate that to the model that we are going to use to try to solve a problem. In fact, we want a model. We don't want just one model. We want a set of models that are going to be tuned to different sets of problems. Like the Mercator model is good for navigators. We've been able to use it as a schoolroom map for the last few hundred years, and I guess it's good enough for that. Although I think some of the other map projections have started to displace it, ones that don't distort size, because they realize if you're trying to teach kids stuff about geography, it's probably more important for them to see the size of things than it is to know exactly what direction things are from each other. And another thing about these models is that they evolve. They don't stay the same. They change with time. In fact, the Mercator map, since I'm using that example so much, it didn't pop out of nowhere. There were these things called Portolan maps. This is an example of one. And it could kind of do what a Mercator map does. It could tell you what direction, different things were from each other, but not every place. It sort of had reference points here and there, and you could see, well, this place is this direction from this place, and then you could kind of try to interpolate between. So it was a sort of, I can see Mercator was familiar with this type of map, and he had this intellectual breakthrough, a way of generalizing this, right? The elegant, deep model. But that would have never happened if it hadn't been for this one. So another thing about models is that even though I love the elegant, deep model, but you can't be too perfectionist about it. You got to have that rough and ready model, and it evolves toward that other thing. That's also where the exploring comes in. And then not only do they evolve, but we need different ones for different purposes. So how does that happen? And that's where that bounded context thing comes in. And a bounded context is one of the most abstract things about domain-driven design. It's a tough one. And I think that the abstractness of this idea is one of the things that's been the hardest over the years. People have gotten more interested in it, especially as we get into the cloud and that a more microservices kind of orientation, and people start getting interested in ways of describing a highly broken down system. But what is a bounded context? Well, basically, you have to be able to point to some part of a system and say, I know that whether I'm in this part or out of this part, right? I can point to an artifact and I can say, that's in this context. This artifact is not in this context. I mean, at a one level, that's what a boundary is, right? You can know when you're in it and out of it. And then, given that, we have to have a team working within there that will keep it coherent and make it nice and consistent and try to cultivate that ubiquitous language within that context. And then over here in another bounded context, we probably have another team that's working to try to cultivate a different ubiquitous language. And they're each focused on a certain set of problems, set of related problems, and trying to find that angle of that problem that lets the business people see it and make important decisions, or other things, but I mean, whatever their goal. Now, I had with my partner a few years ago a community garden plot, and naturally, as happens with me and in almost any setting, I'm thinking, oh, this is like software development. And I was thinking, because we had our plot, right, and this is kind of like a bounded context, right? There's a boundary around each plot. And we get to decide what happens in our plot, and then one next door decides what happens in their plot. They could be growing vegetables. We could be growing flowers. They could be really good at what they do. We could be really bad at what we do. There's a variation, wild variation, and kind of exuberant variation. Sometimes when we think about software architecture, it's a sort of oppressive thing. It stifles and constrains and controls. But sometimes when you're in a place where the architects have a light touch, it's like everyone's being creative and different groups are doing different things, and yet it's all somehow working out. And I think that balance part of that balance is this sort of thing, having the boundaries right, and then getting the right kind of independence within them. But the kind of boundaries I'm talking about, of course, are also boundaries of conceptual models and language. But this community garden thing, you know, it's not a utopia. The plot next to ours, this is an actual picture of the plot that was right next to ours. And that person showed up like once to kind of dig a little bit and left some little planters with plants in them, and then never came back. And then those weeds grew, and it was kind of a mess. And a lot of weeds spread into our plot, which was nearby. Had to spend a lot of time pulling weeds, most of which I think propagated from there. At least that's what I thought when I was grumbling, pulling all those weeds. So even with the boundaries, you know, but the boundaries help because I didn't try to fix this. I didn't try to go in there and pull all the weeds out of the neighbor's garden. The fact that the neighbor had screwed up his garden, and it was an inconvenience for us, but it did not actually prevent us from going forward with our goals within our plot. Boundaries allow that to happen. Not all of a large system is going to be well designed, and we just have to accept that if we really value good design. If we really value good design, we have to find a way then for good design to exist in a system that has a lot of bad design in it. And the community garden, if it's going to work, has to allow good gardens to coexist with abandoned ones. Sometimes you might need more than just a little walkway between each to establish the separation, right? Here's a little more substantial separation of a street environment from a park. Particularly beautiful one, but they're not also beautiful, but an actual wall. Okay, so sometimes you need more separation. But if you are within a place where you can say, well, we've established the boundary, it's marked with this little walkway, and everyone will respect that, then you don't necessarily have to have a brick wall. And then time passes, and, you know, there was a boundary here once. Like, you know, this is, I go for long walks in the forest near where I live, and there are all these, occasionally you come to one of these fences where there used to be, one of these walls where there used to be farms, and a farm on each side, separated this way. And now there's no real boundary there, but, or sometimes we call those legacy systems. But we'll talk about that another time. I actually place high value on those legacy systems. Let's remember, those are the ones that make the money. Those are the ones that make the business actually work. You should hope that someday your system's going to be a legacy system, right? Yeah. Now, earlier I alluded to this. Do these principles help us innovate? This, I think, actually is kind of relevant to this conference because you need an actual community of people that are going to interact and talk to each other and have ideas about, well, how can we do this better? I mean, DDD is an interesting set of principles, but it doesn't exactly tell you how to do everything. And so, like, one of those principles was write software that it expresses the model explicitly. And my examples in the book are all like from, you know, the way that you could do that in 2003 or earlier. But since then, people have come up with innovative things. You know, event sourcing was one of the first really, I thought, oh, you know what? That's a real innovation in domain-driven design that's after the book was done, right? And it really was, it's a really different way of expressing a model. In fact, the model will be different, right? Expressing everything that happens and then constructing the state of the system based on that. Well, that was really a big deal. And of course, it's had a big impact. And there have been other innovations. So that's kind of in that, innovating around that principle. Another one of the principles was exploring models in a collaboration. Well, how do you bring that collaboration around? That was a very difficult thing. I mean, it's still a difficult thing. It always will be a difficult thing. But like some years after the book came out, I put out something called the Exploration Whirlpool. I talked about it in a couple of talks that you can find online. And I think it describes, I realize I wasn't just generically trying to bring about a collaboration. I was doing some fairly specific things, and I tried to describe that. Then, more recently, event storming has come along, and that's a big theme of this conference. In fact, there was a workshop the last 2 days where Alberto Brandolini, who was the inventor of this thing, was teaching that, and he's going to make a presentation during the conference as well. So there's one of those things of basically it's saying this, making this collaboration happen is really hard. And we got to get good at it and come up with techniques. That's innovative. So it really thrills me that people are still interested in DDD. Of course, that excites me. But what excites me more than that is that people don't want to do DDD exactly the way I described it in the book in 2003. That would be sad if what I had done had stuck us in the world of 2003, right? The people who value what I value are stuck in 2003. That would just be sad. Now, sometimes you get some feedback loops between these things, like event sourcing and event storming. Well, I think the event orientation that people were getting in the kind of technical development, how are we modeling this thing, how are we building it, side of things, was part of the inspiration of, hey, what if we drove the exploration thing from that point of view? And so we get event storming. And that inspires me to try to come up with new stuff, like, maybe, events training or events, well, let's not use that. I don't know. There's all kinds of stuff we could try. All right, now onward. Domain-driven design, as people say, and I have emphasized early on, was an emphasis on the domain, not the technology. But although it isn't about the technology, it is not indifferent to the technology. This is like what makes it different than, or one of the things that makes it different from, say, business analysis, which is a big field. And that is that, we're interested in understanding this domain, developing models of it, and expressing those models in software. That's a basic part of what we're doing. And to do that, you need technology. And here is where I think we might be better set up than we were 14 years ago. This might be a reason that, that DDD could actually be more viable now than it was in 2003. Java 5 actually wasn't a bad language, but J2E, oh, really, don't get me started on that. But, then EJBs, but then Spring. Now, these days, people say about Spring's heavy and Spring's this and that. But actually, I was there before Spring. And I remember when Spring came along, it was like a breath of fresh air. I don't know, maybe that's what the metaphor was. By comparison, it was lightweight. It was the beginning of the turn, I think, toward now we have a much lighter sort of thing. But at the time, Spring was still there. I mean, it's still not ideal. SQL databases, I actually love SQL. I mean, relational databases are one of the great software inventions. But the trouble is the word only, right? Everything was SQL, including object storage, right? And, object storage, object relational mappers. Object relational mapping was an invention of the late 90s, as I recall. It wasn't meant to be like, well, this is the way we will do this forever, but it turned out to be the way we did it for at least 10 more years, 15 maybe. And I don't want to be too hard on like all these things, because every one of them, people were trying to do good stuff. But they do follow a pattern, you know, from that time. There's a kind of heaviness to them, a kind of awkwardness sometimes. So I think that, you know, things just, well...
Couldn't you build some form of computer aid here?
In this zinc-plated, vacuum-tubed culture.
Well, so, you know, maybe we were just expecting too much. That's the next line in the show. All right, maybe it's just too hard to express the kind of model I'm talking about in software in 2003. Maybe it still is. I don't know. I mean, you know, we haven't really proven that this thing works yet. But to express a ubiquitous language in code, I've done it multiple times, but it doesn't just roll along. It doesn't seem as easy as it ought to. I think it's a little bit easier now than it was then. You know, and then this whole concept of aggregates, which I won't get into, but we didn't really have a good way to do that, although maybe, you know, sometimes people now they're using document databases, and that seems to have a concept that maps to aggregates a little bit. Oh, I made a big deal about value objects should be immutable, and that was so hard. I don't think it was even hardly worth trying. But on the other hand, now, the functional programming languages really emphasize that. But you can make an object that's sort of mutation resistant, and that's pretty valuable. It's just that if the technology supports you in these things, then you can turn your mind to other things, like coming up with better models. But if it's all you can do to just sort of make an immutable object, then, you know, you're not going to have a lot of creative, you know, marking context boundaries. I think that's still a hard one, but you have things like in the microservices movement, suddenly there's this attitude that at the very least, it's okay to create a boundary within which you duplicate some data. You make things truly autonomous. You let people kind of do what they want in there and expect that it's not going to be the same as what's outside. So I think some of the conceptual obstacles to creating good bounded contexts have lowered. People are not afraid of having a database, a little personal database for this chunk of the system, for this little service or whatever. So there's not everything about microservices is good, of course, and I think we've passed peak buzz on microservices, and now everyone's going to soon be saying what a terrible fiasco it was or something. But actually, there was some really interesting stuff there, and I hope we don't throw the baby out with the bathwater on that. And I say that particularly in reference to context boundaries. So what I'm getting at here is that maybe 2017 we are better set up for DDD than we were back then. You know, we haven't made it there, though. I feel like, for one thing, most projects still use a technology stack that isn't all that much different than the 2003 one. Though you see more and more breaking away, but you know, we're not there yet. Oh, so I think about, you know, if you're playing Twister, naturally you think about software development, and you think, oh, this is just like OR mapping. Okay. So, you know, we have more options now. NoSQL. In-memory data is a big deal now because memory is cheap, which it wasn't really so cheap in 2003. Event sourcing, where we don't have the same kind of data structure at all. We create it when we need it. And of course, relational databases. If we ever can get back to the idea of relational databases used for relational models to really do relational computations, then I think they're going to have a whole resurgence. At least that would be kind of a nice thing. And then we have message orientation, and everything's all neatly decoupled, and messages are flowing here and there, and okay. So let's move on. So I do think that there are things that favor us. You know, there are some headwinds here. One of the big ones is the way libraries are written. The library, you know, I listed out the basic technology stack of 2003, but the basic technology stack of 2017, actually, it'd be hard to list that out. There's so much variation. But most of them are very lightweight, sort of, you can kind of take this one and that one and put it together, and people do a lot more mixing and matching. And that's so nice. And there's a lot of innovation right now in programming languages. Still, most people use Java, although Java 8, I must say, is like a different language, much nicer. And so we have a lot less noise, I think, in the programming itself. That helps when you're trying to express, you know, trying to make something read like language, read like I'm reading about the domain, right? It's hard to do that if if 3/4 of your code is boilerplate and everything's all kind of weird. I do think we are in an era of experimentation. That can't last forever. It'll last for a few years, and then there'll be a kind of consolidation, a shakeout period. That's the way it almost always goes. But and it's a pretty wild ride. I almost feel like I could take a breather at this point, but we're going to end up in a much better place. I think, for example, the shakeout's already begun. A few years ago, there were more NoSQL databases than there are now, I think. And another thing, and so overall, I feel pretty optimistic, actually, which is just, it isn't like me. So, you know, I think that all these things make me feel a lot more optimistic. Now, we have, in 2003, basically, object-oriented was king. And I loved object-oriented. I was there in the 90s when it was kind of new in commercial application. And I loved it, but I don't love anything being the only thing, right? When you've only got one approach. So now, I would say we have at least 3 viable ones. Object-oriented, which I still like. And, you know, so when you're thinking about objects, you do certain kinds of things. You have certain ways of abstracting things. You have classes and methods and references to other classes or other objects. And then you have a way of like attaching little procedures to some data so that you can encapsulate stuff. You know, object-oriented, everyone knows that. But if you think about it as one paradigm among many, you start to think about it. And event sourcing, to me, is like a different paradigm. Usually when you do event sourcing, you are also using objects. And so you're going to like do a projection. And that projection will be an object structure. But it really takes a different attitude. You know, you've got this sequence of events, and then you sort of infer things from that. But it's still got a lot of the same concepts in terms of, well, we got to express our these events in terms of, well, this event happened to something, so there's an entity there, an identity anyway, that is associated with some entity, and then I got to describe what happened, so there's got to be some value objects involved. So we still got this kind of, some of these same concepts still work. Now, relational, one of my favorites, really. And relational, I honestly think, was killed by this concept of having this comprehensive schema, make it have all the data, a sort of a canonical model of all the data. But if you looked at it the way I was talking about models earlier, where you're saying, well, I want something sort of focused that can help me solve a problem. There was this one time I was on a project where we had some successful object-oriented work, and we came to the next problem. This problem involved basically within a big bank, if you've got lots of mergers and you need to figure out if you've got like different accounts from the same person, how do you know it's the same person? And so we were working on models to help us figure that out and do the rules, but the actual processing was extremely slow, and the code was somewhat complicated, but mostly it was just slow. And as I was looking at it, I thought, this seems like a relational problem. I mean, it just seems like it might fit that better than objects. And we did a little experiment. And there was one guy on the team that was a real whiz with SQL, and so he did most of the actual figuring out. And we expressed the rules, and the rules as expressed in a SQL statement were more readable than they were when we did it in C#, which happened to be the language we were using before. And then when we actually ran it, and the whole thing was like less than a page of code, and we ran it, it ran like this thing which they had to run in less than, I can't remember, they needed to be able to get it turned around in less than 24 hours, I know. And the batch they thought for a realistic data set was going to run about 12 hours or something. And suddenly it was running in like 10 minutes or less. That's what, when you find a good fit to the problem, right? When you find, so not only a model that fits the problem, but in this case, a modeling paradigm, relational model, and as an actual model, not just as a data store. And so what happened, by the way, is that after I came in as a consultant, so you come and then you go, and I thought, wow, this is a real win. But I heard a couple months later that they had gone back to the object-oriented solution. So it was an emotional attachment. I think part of it was this thing seemed too trivial, right? And anyway, old-fashioned. We don't want to do it that old-fashioned way with a relational database. That's very sad. But I think that it would have been a better chance now. That was several years ago. It would have been a better chance now of getting people to embrace such a solution for that one context. Functional programming, I've done quite a bit of closure programming in the last 2 years. It's a fun way to think differently about programming. And you really do have to think somewhat differently. And I think functional is more than one thing. So really, I'm talking more about closure or Lisp. But you have functions, and you've got sequences and maps, and everything's a map being mapped to another map. And it's a different way of thinking. It also, I think, it's a good fit for event sourcing, probably. So there's another viable kind of paradigm that we can work in. Now, graphs is one that I feel like it's there on the edge. And I know people are using it like for recommendations engines and this and that. So there's another thing where you say, well, okay, we need a model, and it's more a model of how things are related to each other and the strength of those associations. And it's good at doing kind of fuzzy things. And, I'm not an expert in graphs. But what I'm getting at here is that certain kinds of problems are well suited to that. And if you start to model within that paradigm, you think differently. If I were going to do an OO-based recommendation engine, it would be very different than if I'm saying, I want to express these things in a graph database or whatever. So, logic and rules engines is one of the ones that I wrote about in my book. And I even said, I think someday this is probably going to be a good way to do domain-driven design. Well, not yet, but maybe someday, I still think it's a good idea. So I do think the winds are shifting somewhat in our favor. We're less, people don't just say, well, the monolith is good enough anymore. There's really serious attention to that. And we don't have the same monoculture that we had a few years ago. That monoculture was deadening. And it isn't, I seemed awfully negative about the various frameworks and the technology stack that we had in 2003. But what I really am negative about isn't those particular ones. It was the fact that those were the only ones. That was the only way it was done. right? Each one of those was real solutions to problems people were actually dealing with. But it was the only set of solutions. And now we don't have that. We don't have that monoculture. So in a world, though, where you are seriously having to use distribution or concurrency, eventual consistency at least, suddenly careful design might start to pay off more, especially loose coupling, well-defined contracts, things which you can get away with an awful lot in a monolith that you can't get away with in a distributed system. And so the hope I have is that because this makes people value it. See, I think there was a huge payoff to be gained anyway. I was very confident of that. That was the whole point of what I wrote a book about. But that's not always the thing that sells it, right? But what will sell it is, well, we need to scale this thing, and we just can't scale it because we've got all our, these data updates are all tangled together, and we can't make the eventual consistency really work. If you can't scale, then your business is dead in the water, and you know it, and you know why. Whereas if you are, well, you really should have been able to have a richer model, a better fit to the real business problem, and all that stuff, it's harder to get that across, I think. So I'm hoping that we'll get to ride a little bit on that desperate need for cleaner design may go along with a cleaner model of the domain as well. It's very hard to get eventual consistency to work well without some attention to the domain model, I think. So anyway, these are my hopes. And one last thing I think that's really different than 2003 is the prevalence of open source software, not because of the software's utility. We had lots of good software that was made for money, and we still do. And I'm actually a big fan of open source in many ways, but the particular way I'm talking about now is that you get to see what they did. You get good examples. Back when I started in object-oriented programming, I was doing Smalltalk. And one of the things the Smalltalk, more senior Smalltalk people always said was, well, just look at code that people have written. Look at the libraries in Smalltalk, for example, which were nice examples of well-written libraries. And then you learned from that, and you learned from seeing good code. In the open source world, you get to learn from seeing good code, right? As long as... So I think that's a big thing. And I think, too, that we also want to show our stuff, right? And we exchange, and it creates a whole conversation around the design. I myself am trying to loosen up a little bit and open up. You'll see, and I'm going to talk about that in my other talk. But the idea that we have a way of trying stuff publicly and saying, yeah, that works, that doesn't. Because one of my big frustrations is I have a lot of interesting experiences on projects, most of which I can't talk about because I've signed every kind of NDA. And so I can't talk about the things that worked and the things that didn't work, except in generalities or by sort of camouflaging it a little bit, making analogies and stuff. And open source is different. Plus, you can, actually in the code. So maybe that's thing. Now, the alternative, there's always an alternative. An alternative to careful design and modeling is to just build stuff and just fit stuff together, and you can make stuff work, right? I think that if you have a goal, let's say, you want to turn a page in a newspaper, you can always make it work. But it may not be all that scalable, right? It may not actually lead you to, of course, I think that the limitations of the physical world mean that you have reliability problems. But in the software world, we don't have to worry about that. If you get the code to run once, it'll run every time. And so you could build a Rube Goldberg machine, and it would actually work. And that's what we do. I mean, not the people in this room, of course. Present company accepted. We pretty much, as an industry, build the most amazing Rube Goldberg machines, compared to which this is like nothing. But, oh yes, the Post-it note. We love Post-it notes, don't we? There's a use for Post-it note that I'll bet even Alberto has never come up with. So here we go. It's going to do something useful very soon now. And that, I think, is the thing, of course, that makes this particular one interesting to me. You know, you see lots of Rube Goldberg machines, but there's one that actually did something useful. I could easily imagine the business people, us coming in and saying, this is a terrible way to turn a page. And they say, well, it works. I was just going to play over and over. We can stop it now. But, So I think that's, of course, why we want to do good design, right? I mean, and domain-driven design is one of the schools of thought within doing that kind of nice design. One that maybe emphasizes that, yeah, you know what? There are going to be a few Rube Goldberg machines here and there in our software, but then there will be places, islands, where we've managed to carve out a little space and do something really elegant. And if we choose wisely and we are doing something important in that little elegant space, then it'll have a huge payoff, right? And that's what I mean about, you know, distilling the core domain. So on that note, so let's go out and let's learn some more, innovate some, share all these experiences, and have a really great conference. And thank you for your attention.